Okay, hello guys. It's good to have you here again today. We are going to be looking at this project. All right, 0 times 0 AC argument C argument V. This is the project we are going to be looking at today. All right. Let me quickly say that if you are coming across this channel for the first time, please kindly subscribe. It's very important to encourage us, to keep us. Like and subscribe to the channel, like the video, and if you are a returning subscriber, kindly watch this video to the end because we will be explaining and you are going to get a lot of value from this, believe me. All right. So again, these are the resources for this project. I will advise you really go through them, all right, so that you can glean a lot of knowledge. Okay, but either way we will try to see how we cover a lot, but also try to look through the resources. It's very important. All right. These are the general requirements. You are allowed to use vi, vim, or emac, and all your file will be compiled on Ubuntu 20.04, and all your files should end with a new line, a readme.md file. Of course, you already know that, and your code should use the Betty style. It should be Betty compliant. Of course, it should follow the Betty documentation style, and you are not allowed to use a global variable and no more than 5 function per file. The prototype of all your function and the prototype of the function underscore putcher should be included in your header file called main.h, and don't forget to push your header file. You're not allowed to use standard library. All right, so I just needed to do that because the requirements are very important. Always ensure you check through. All right. Okay, so what are we doing next? The next thing we are supposed to do is to look through the quiz. All right, but we can't do that if we don't have an idea about what we are doing. Like right now, we need to know what this stands for, what we are doing, and what they mean, and all of that. Argument C and argument V, what do they mean, and why we are looking at this right now. All right, so that is the next thing we are going to look at before we even go through the quiz questions. Okay, so all right, permit me to open this. All right, so this term argv or argv actually stands for argument vector. All right, and it's a variable that contains the argument passed to a program through the command line. Okay, it contains the argument passed to a program through the command line. All right, so again, a vector is a one-dimensional array. All right, and argv is a one-dimensional array of a string. I believe you should be familiar with what arrays are. Okay, I believe you should, at a point in time you should have come across arrays. All right, arrays, they are just, they help to hold values. Okay, so, and what we are saying here is that a vector is a one-dimensional array, and an argument vector is a one-dimensional array. It's a one-dimensional array of strings. All right, so as you know, an array starts with 0. The first item in an array is usually 0, the next is 1, then you have 2, and so on and so forth. So that is what this is. All right, then you have argc or argc. It stands for argument count, and it is the number of arguments passed to a program. Okay, this is the number of arguments passed to a program, and it's always includes the program itself. All right, if you want to start to count, you have to start counting from the program name itself. All right, that is what this stands for. Argument C, okay, is the number of arguments passed to a program. Or the number of arguments on the command line. Okay, you can put it that way, the number of arguments on the command line, or the number of arguments passed to a program. That's what argument count, that's the meaning for that. Okay, so if we have this, all right, if we have this as the arguments in a program, all right, and GCC be the program name itself. Okay, remember we said that the number of arguments begin with the program name itself, or the program itself. So what is the number of arguments here? All right, if we want to start counting, we have to start counting from GCC, which is the program itself. So this is 0, this is 1, this is 2. Talking about the argument vector right now, this is 3. So in all, the program count, the argument count, sorry, how many? 1, 2, 3, 4. They are 4 in number. So argc or argc is 4. All right. Okay. So what is argv? 0. So for this array, the first item, which is always denoted with 0, is what? Is the program name itself. You have to start from here, which is what? GCC. All right. And argv, the second array in this argument is this. So that's what you have here. And the third array, which is 2, which is represented by 2 in this argument, is this, which is this probe. Then the fourth array, represented by 3, is what? Probe dot what? Dot C. All right. I believe this is the starting point. All right, you have to understand these basics, all right, for us to get started. Okay, so I'll quickly come back here. Okay, since you already understood that, what we have just explained, we are going to then show the quiz questions and do some more explanations. Okay, so I'll open this and we'll look through it. So he said, what is argv, or argument vector? Okay, the first one is an array of size, an array containing program compilation flag, an array containing the program command line argument. Like we just explained, that argument v is an array containing the program line. All right, or a variable that contains the argument passed to a program. You can put it either way. Okay, a variable that contains the argument passed through a program or a command line is argv, or argument v. And an array of size, yes, this is true, it's an array of size argc. Okay, it's an array of size argument c. Argument c stands for argument count, so it is an array of argument c. So move to the next one. Question 1. In the following command, what is argv 2? That means the third array in the element, in the items. So like we explained, this is the program name, yet it is our first item in the array. So we have to count from here. This is 0, right? This is 1, okay, and this is 2. So for this is what is fun. So this should be the correct answer for that. All right, I believe you understood what I explained there. So for this question 2, in the following command, what is argument vector 2 in the array, which is the third element in the array? Again, here the name of the array is the first item, which is always what? 0. Okay, and here this is the second item, which is 1. Okay, so there is no 2. There's no third element in this array, so that's why our answer is what? Is null. There's no third element in that array. Okay, so what is argument v 0? Okay, yes, first command line argument null. It does not always exist. The program name, this is what we have been saying. The program name is argument 0. The program name is, you have to start from the program name itself. Okay, that's the first element in that array. All right, for this question, for in the following command, what is argument v, the third element in the array, which is 2. Okay, the program name, like we always say, is 0. All right, then this is 1, this is 2, this is 3, and this is 4. So for 2, which is the third element in the array, this first element, second, third. All right, so this is it, 0, 1, 2. So that's why our answer is this. All right, I believe you understood that and you are following what we are doing here. Okay, what is argument v, then an array of argument c? That will be null. Okay, that will be null. We talked about that in the previous question. Okay, what is argc? This stands for argument c, argument count. Okay, and what is it? Like we said earlier, it is the number of arguments on the command line, including the program itself. Okay, so again, it is the size of the argument vector array. So this is it, number, size, the number they are, that's the size. And this, it is the number of command line argument, number. All right, so that is why these two, I picked these two, that's why they are correct. So if you haven't done this, I believe from the explanation I've given, not just showing you the answer, but telling you why we picked what we picked, I believe is going to help you in this project. Okay, so I will just go ahead and hide this quiz section, and we move on to, go ahead to start solving the task. All right, so let me split my screen. Okay, so I've opened the terminal. So the first thing we have to do now, going by the requirement, is to create a readme file. All right, so I'll just come here. Okay, this is the root file. Let me be sure that I'm in the root by doing cd/root /root. So I'm sure I'm in the root. I'll then navigate to the ALX low-level programming directory, GitHub repository. So I'll do cd Ctrl-AV. All right, so have you done that? The next step you should take at this point is to create this directory. Okay, is to create this directory. So I'll go ahead, just come here, I like that, use Ctrl-C, copy, come here and do mkdir to make your directory. You paste the name of that directory, Ctrl-AV to paste. So if you go ahead and click enter, it's going to create that directory. But for me, since I already have, if I click enter, it will tell me that cannot create because this already exists. All right, but if you are doing that for the first time, it's going to go ahead to create your directory without this error message. It's not going to prompt this error, but I already have that. All right, since I already have that, I'll just go ahead and do cd. I'll paste that name. So if I click enter, you see we are now in this directory, this 0 times 0a argument c underscore argument v directory. All right, so that is that. So the next thing we will have to do now is to create our readme file. Okay, so how do we do that? You come here, you do vi, readme.md. Okay, so click tab. So this becomes your readme file. How did I get this? Like I will always explain, that is very easy. You come here, you copy these task questions. All right, this is what you have. It isn't what they call it. This task 0. That's what you have here. Just copy the task questions and put them into the readme file individually. You can copy and put in your notepad. Meanwhile, the document for this the readme file will be in the document. The link will be in the video, the description to this video, so you can just copy that and put it to your readme. So this is the readme file. Middle page down. All right, so this is the content of this readme. All right, so that's what you have there. So after putting in the content, putting in your readme content, the next thing you have to do is to exit, tap your escape, then do your :WQ to save and quit. All right, so have you done that? That means you have successfully created your readme.md file. Okay, so the next thing you should do right now is to create your main.h. all right, this main.h. you have to create this main.h. So how do you do that? You come here, you do vi main.h. okay, you press enter. All right, so this is it. Just hold on, I don't know why this is. Let me just escape and do this again. Don't have to worry, this is just normal misbehavior of the terminal. Okay, you do vi main. Meanwhile, the document, the content of your main.h file will be in the document. The link will be in the description to this video. You can always look through and copy, pick the code from there. Okay, yes, that's what you have. This is your main.h. Just put this few lines of code into your main.h file. All right, yes, just put this content into your main.h file. When you are done, you can do your escape :WQ. all right, okay, so have you done that? That means you now have your readme file as well as your main.h file. There is another file, the _pusher file. You don't have to push that. Okay, the code to the _pusher file will be in the link. All right, but you don't have to push that file. So I'll just go ahead and move to the next one. Okay, so the next thing we want to do right now is to start solving the project task, since we already created our files. All right, so the first one we have here is task 0, which is, it isn't what they call you, it is what you answer to. Write a program that prints its name followed by a new line. All right, write a program that prints its name followed by a new line. So we are going to go ahead, copy the file name, copy this, I come here, do vi, Ctrl V, I paste that in. All right, so press enter. All right, so let me just take a little time so that we can look through this. This is the header file, include main.h. This is the header. Like you know, this is the comment. Alright, this is the comment. I believe this is not a big deal. Talked about the main, praise the name of the, this is just the comment section. Okay, so coming here, you have your function. Alright, your function. Okay, so this is the function name, which is main. Alright, main is the function name, and this main is a function returning what? An integer. Alright, this function is returning what? This int. This int stands for integer, so this function main is returning what? An integer, and these are the argument passed into this function. You can also call them parameters. So these are the function what? Argument. Alright, integer, argument count, attribute underscore used, and all that, and this is pointer to an array. Alright, this is pointer to an array. Okay, so let me also explain what we have here. Okay, this is printf. It is the standard output, okay, in C programming to output this. So this is printf, and this is your format specifier. Okay, this percentage s is your format what? Specifier. You have different format specifiers. Let me just open this. Okay, so you can look through this. These are format specifier. What is a format specifier? A format specifier defines the type of data to be printed on the what? Standard output. So you need to use format specifier whether you are printing formatted output with printf or accepting input with scanf. Alright, so what are the format specifier in C? So you have this modular C, single character, modular S, a string, which specifies a string. I believe this is what we have here, so that's a string. Then this, all of this, and prints nothing. Then the other popular one is modular D, which is a decimal integer. Okay, that's also popular, and others. So you can just look through this for format specifiers. Alright, so that is what we have here. So in C programming, you have to specify the format. Okay, the format of your output. So printf, it specifies that this is what? A string, and printed in a new line. Then you print out this this argument v as a pointer to an array. Okay, returns 0. When the program returns 0, that means it is a success. So this is basically what we have here. Alright, it's basically what we have here. Okay, so just include this, run this in your put this into this file. Alright, I already explained this. Once you are done, you do your escape :wq. So since I'm not saving, I'll just do :q, press enter. So it's going to bring you here. Alright, so having done that, the next thing you have to do, you do your Betty to be sure that what you have there is Betty compliant and follow the Betty documentation style. So I'll do Betty, I'll paste the file name. If I press tab, it's checking for Betty. You see, it didn't return any error. So that means this code is Betty compliant and followed the Betty documentation style. So have you done that? The next thing you do is to push it to the remote repository by doing git add dot, it means all, you are adding all. Then you press enter. Have you done that? You press enter. Then you do your git commit space -m. Then you put it that your commit message, you close that, you press enter. Then have you done that? You do your you do your git push, and press enter. Once you do that, your code will be pushed to the remote repository. Then when you are done with that, you can come here and check your code. You're ready to check right now? All right, let's check. So you see this is all correct. Once you follow the steps outlined earlier, your code should check correctly. All right, so I'll close this. So when you are done with that, you can then move to the next task, which is 1. Silence is argument carried out by other means. Write a program that prints the number of arguments passed into it. Write a program that prints the number of arguments passed into it. So what we do first is to copy the file name, Ctrl C, come back to your terminal, you do VI, Ctrl AV, you paste that in, press enter. Alright, again, this is the content of this file. Alright, one argument.c, this is the header, this is the header, then this is the we are including main.h here, then this is the comment section. All right, then this is the program proper. This the function we have here, like I explained earlier. The function name is main. All right, believe you understand that. And main is a function returning what? An integer. And these are the function this is the argument passed into this function. You can also call it parameters. Okay, so this is void. All right, this is void. It means that this should not be taken into account. You can as well come here and put the brackets without putting anything into it. All right, okay, so the comment here said ignore argv. All right, that's the void here. Ignore this. Okay, then you have printf and modular d. This is the specifier. Okay, this is the format specifier. Then you have your argument c, the -1. Okay, then return 0. If it returns 0, that means this program is what? It's successful. Okay, so that's what you have there. That's what you have there. So once you are done with that, you can press your escape. You can do your escape, shift column WQ. All right, I'll just do column Q since I'm quitting. All right, press enter. So once you are done, you can do your Betty. Okay, do your Betty, run your Betty, your file name, to be sure that all right, you see that Betty did not throw any error, so you can then go ahead and do your git add all. You press enter. Then I've done this before, so I don't need to push my code multiple times. Git commit -m, then your commit message. Of course, we use the file name here. You press enter. So having done that, you do your git push and press enter. Once you are done, your code will be pushed to the remote repository, and you can come here to check. So we are running our check. You see it's all correct. So if you follow exact same thing I said here, you should have the same result. I'll close this. We move to the next one, which is this. The biggest argument against democracy is a 5-minute conversation with the average voter. write a program that prints all argument it receives. Okay, so we'll go ahead to copy the file name, Ctrl C, come back to our terminal, we do VI, Ctrl AV. Alright, so this is what you have in here. Okay, we are including the standard input output .h, then include main.h. This is the comment, this is the comment section. Then this is our code proper, which is the function name, main. Then our function is returning an integer. This is the function argument or parameters, and we are initializing a variable I, okay, as an integer. Okay, you have to specify the format of your variable. This is an integer, and we are using a for loop here. Okay, for I equals 0, as long as I is equals 0, I less than argument C, increment I. Okay, increment I, which is I plus plus. For I equals 0, and as long as I is less than argument C, increment I. So once you are done, you print, you know, this is a string, the format specifier is a string, print it in a new line, and print argument this variable I. Okay, so return 0. Alright, so this is it. This is what you have there. Just as simple as that. Put this into your file. Once you are done, you can do your escape :WQ. Alright, you get out of here. You can go ahead and do your Betty file name. Alright, once you are done with that, then you do git add dot, you press enter, then do git commit -m commit message, which is the file name. That's what we use here. You press enter, then you do your git push. You press enter. Once you are done, you go ahead to check your code. Alright, you come here, check your code. It's checking, so it's all correct. So having done that, we move to the next task. Neither irony nor sarcasm is argument. Write a program that multiplies two numbers. Alright, write a program that multiplies two numbers. So once again, we go ahead to copy the file name here. Ctrl C, do VI, Ctrl AV, we paste that in, we press enter. Okay, don't worry, let me just go ahead to cover this. Alright, so this is what you have here. Let me do page up. Okay, so this is it. So this I'll just go ahead and do this. We are initializing our variable I, D, N, length, F, and digit, and we give them the value 0 for all of them. So we use our while loop. Okay, while this length is not equal to 0, increment this once, while this is less than that, and F is exactly 0, and if S is this, okay, increment D. Alright, so that is what you have here. Do page down. All of time I might not be able to do much of a detailed explanation, but so this is the end of the code. Alright, so look through it, put this into your file. Okay, look through, put this into your file. All right, once you are done, do your escape column WQ. You get out of terminal. So once you are done with that, you can do your betting. Do your Betty file name. Start doing Betty, then you can do your git add dot enter. Do your git commit FOM, your commit message, tap enter. Then after doing that, you can do your git push your code to the remote repository. So once you are done, you press enter. If you did that correctly, you can come down here to check your code. So run our check right now is checking, it's all correct. So if you follow our lead, our examples, you should be able to get exact same result. So the next one, okay, the next one is this: to infinity and beyond. Write a program that adds positive numbers, okay, and print the result followed by a new line. If no number is passed to the program, print 0 followed by a new line, and if one of the numbers contains symbols as not digit, print error followed by a new line. So the series of instructions are there. You can go through it, you know, to be sure you are doing you are following the right, you are doing the right thing. So I'll copy the file name, Ctrl C. I'll come here, I'll do VI, Ctrl AV. Alright, so this is the content, quite lengthy though. This is the content, okay, of this. Alright, so the first one, so there are a series of comments here. First, this is the, we are including a standard input output ender, include standard library.h. We are including ctype.h and string.h. These are the series of headers we are including into this file. Okay, this is the comment, and here you have this is your function. This is the function name, which is check num, and our function is returning an integer, and this is the argument passed into the function. This is a pointer to an array, okay, a pointer, okay, to a string. All right, here we are declaring this variable count as an unsigned what integer, and count is equal to 0. We initialize count to be 0, and where count is less than a string length, okay, so this line helps us to count our string. Okay, this line helps us to count our string. This code helps us, this line of code helps us to count our string. And if is digit string length array count is not okay, if is digit is not array count, okay, check if string there are digits, okay, then return 0. Okay, if not, then go ahead and increment count. All right, then at the end of the day, when the program return 1, it is a success. All right, the success. Let me do page down. Okay, for the next one, we declare our variables. Integer, this count, our variable count as an integer, then string to integer as an integer, then sum, initialize it to be 0 as an integer, and say count initialized as 1. While count is less than argument c, goes through the whole array. So this is what this does. It goes through the whole array. And if check num argument v, an array of count, then string to length is equals at oi argument v count. Okay, convert this at oi, convert string to what? To integer. This is what this does. So once that is done, then sum this. Okay, once if you sum, you increment. This was sum and increment. This is what this stands for. And condition if one of the number contains symbols that are not digits. Okay, s printf error. If this condition is not met, print output an error, throw an error and return 1. Okay, then or if not, then count plus plus, increment your count. All right, at the end of the day, printf this your format specifier, which is what I need, like the format specifier which we talked about. All right, again, this is a decimal integer. Okay, for d. So this is what you have there, then return 0. So this line of code will print your what? Your sum. Alright, so you can look through the code. I just did a summary of what you have there. So once you are done, you can click your escape, then column WQ. Alright, and press enter. So go ahead and do your Betty file name. Alright, Betty is correct, no error detected. That means our code is Betty compliant and has followed the Betty documentation style. So you go ahead and do your git add dot, press enter, do your git commit. Your commit message, because the file name, you press enter. When you are done with that, you can then do git push to push your code to the remote and press enter. So once you are done with this, you can come here to check your code. So run this check. So it's all correct. You see, it's all tick green. So if you follow this lead, anytime you are confused, just play back, go back, to the point you are lost from, and play this video again. All right, you understand what we did here. So the next one, minimum number of coins for change. Write a program that prints the minimum number of coins to make change for an amount of money. Okay, write a program that does this. Usage this dot slash change cent. Yes, cent is the amount of cent you need to give back, and if the number of argument passed to the program is not exactly 1, print error followed by a new line and return 1. You should use at oi to pass the parameter passed to your program, and if the number passed as the argument is negative, print 0 followed by a new line. You can use an unlimited number of coins of variable 25, 10, 5, 2 and 1 cent. Wow, quite much. So let's copy the file name. Ctrl C to copy. Then you come here, do your VI, Ctrl AV and paste. So this is what we have. Alright, so again, we are including our main.h header file. Then these are comments, and this is our function. Okay, this is our function. This is the function name, which is returning an integer, and this is the argument to our function. So the next thing we have here, we are initializing a variable, integer variable num, j and result, and we are writing an array coin. All right, as an array, and that the format is it's an integer. So for this, we have here an array 25. The items in the array 25, these are the array items, and if argument is not equal to 2, argument C, then print error. Alright, so S, you return 1, and if num is equals to at OI, then the first element in this array, first element, argument vector, first element, of course, if this is 0, then this is, sorry, the second element, this is 1. If this is 0, then this becomes what? 1. Alright, then result equals 0, and if num is less than 0, print F 0 in a new line, return 0. For j equals 0, as long as j is less than 5 and num is greater than or equal to 0, increment j. So while num is greater than or equal to coin j in this array, alright, in that array, then increment your result. Increment your result. And if num is decremented and is equal to coin j, then print F decimal integer result. Alright, then at the end return 0 if the program is true. That's just what you have there. Okay, that's just what you have here. So put this into your file, put this into your file. Alright, once you are done, you can do your escape, column WQ, you press enter. So you can go ahead and do your Betty file name. So Betty is clean. Betty did not detect any error. So go ahead and do your git add dot. Alright, press enter. When you are done with that, do your git commit -m commit message. Press enter. Have you done that? Then you can now do your git push. You press enter. So once you are done with all of this, you can come here to check your code. Are you ready for this right now? So you run this check, you see it's all green, we are correct. So if you follow to this point, congratulations, because we continue to do this, alright, to give you this kind of quality video. Ensure you like and subscribe to this channel. Subscribe to support what you are doing, and we'll continue to give you wonderful and amazing content, and I'll give you guides on your programming journey. Alright, so I believe this is it for this video. Before I go, let me just do a quick recap. Okay, we talked about this. Alright, you can just look through this concept. I believe they are very important to what we did today. And again, these are the steps you go through to create your files, your readme and all. You go through these steps. Okay, this is a guide, just a summary to what we did here. You can look through it. This is the summary, and the document which contains the content of this file will be dropped in the description to this video. The link will be dropped there. You can open it and look through, and type out the code yourself, which is better, or if not, you can copy them and paste in your terminal, and you do that. Alright, so we always ensure we give you amazing content. Please like and subscribe to this channel. Thank you. I believe this is it for this video. It was an amazing time. I'll see you in the next one. Thank you.